episode of the Dark Assassins podcast, the show that dives deep into not just technology, but the concepts, software, and procedures behind it all, and explains it so simply that even your grandma can understand it. As always, I'm your host, the Dark Assassin. So we are going to revisit a topic from last week's episode. So if you haven't listened to last week's episode, you're probably going to want to do that, because last week we talked about cache and cache performance and why optimizing your programs for more cache hits can greatly improve the performance of your program. And in this episode, we're going to dive even deeper into that, because pretty much as soon as I recorded that episode, I wasn't exactly too happy with how I discussed, the potential performance increases that you could see if you had more cache hits rather than cache misses. So, of course, being me, I decided to write a sample program to basically demonstrate cache hits versus cache misses, just to show the difference between how the exact same program, where optimizing for cache hits, if you optimize for cache hits with the exact same program, just the massive amounts of performance gains that you can see just by doing a small, literally, 2-character change to the code. So we're going to be getting into that later on in the episode. But before we get into that, let's start off with our trivia question for the week. So we talked last week and this week, and we're going to talk about it this week, about MS-DOS. But what does MS-DOS stand for? So what does MS-DOS stand for? And that is your trivia question for the week. So we have a decent amount of Apple news. Not a lot of it is that good. There was a vulnerability discovered in all of the M-series chips, which technically didn't happen this week. I think it happened last week or the week before. But there's basically a vulnerability in all the M-series of chips at the hardware level, essentially, which can basically potentially leak user credentials, and it's really bad. The good news is the only way to exploit this is if you have physical access to the system and have a bunch of knowledge about how the attack works, and there's a lot of sophistication involved. So if you have an M-series Mac, I don't think you're necessarily in any danger of you're going to be exploited within your time's ticking, and nothing like that. But definitely something to note. But going to some good news, though, they did announce WWDC, or their Worldwide Developers Conference for 2024, and it is going to be the week of June 10th. And yes, I said the week of June 10th because while they have their keynote event at the beginning on June 10th, the actual conference itself runs for basically the entire week, and they have various hands-on demos and labs and various things to help developers get on board to all the new features coming to their latest operating systems. But that is going to be coming on June 10th, so definitely going to be looking forward to that. I don't think there's necessarily going to be anything too out of the ordinary. You're going to get your standard operating system updates. I guess the only difference now is, in addition to the standard iOS, watchOS, iPadOS, and macOS, we're also going to get visionOS now, I guess. So aside from that, not too much I don't think that we're gonna be expecting. Last year, one thing that I was really looking forward to see was with the whole potential of Vision Pro, what the simulator would look like in Xcode, that kind of a thing. As far as this year goes, from what the rumors are saying, there's supposed to be a very heavy AI focus because, of course, there is, because everything has to have AI these days, which actually, funny enough, we're gonna, a little later in the episode, we're going to kind of go through some technology buzzwords. And because I saw a post of going over some technology buzzwords and what they really mean, like if you translate the buzzword into, English, what it actually means. And stuff with AI is one of them. Which I think is kind of funny and pretty good. So we're going to get into that a little later. But staying on topic here with Apple, in addition to them announcing WWDC, some governments announced various lawsuits against them, one of them being from the Department of Justice here in the United States, filing an antitrust lawsuit against Apple for essentially claiming that they're like a monopoly over their ecosystem and making it hard for Apple users to switch to Android. There's a bunch of nitty gritty that goes into it, but there's that, and then Apple's also apparently having legal action filed against them in the EU for their compliance or lack thereof, some would say, or their malicious compliance with the Digital Markets Act, or DMA. So Apple's in some pretty big legal trouble, although, it's not like this is the first time they've had lawsuits filed against them. I'm not sure how many they currently have. I think there's that one with the Apple Watch still going on. There's these two new ones. I'm sure there's multiple others. Not too long ago, I think they filed or they settled the one with the battery gate thing from like the iPhone 6. I think it was the iPhone 6. Or the whole thing with them basically throttling iPhone performance in order to save battery life without telling anyone, and essentially decreasing the overall usability and performance of iPhones without telling anyone. So yeah, that recently just concluded. So they've kind of always been in legal trouble, which I think that it's safe to say that pretty much any company that's close to or the size of Apple deals with multiple lawsuits on a recurring basis. It's just kind of comes with the territory, I guess, especially, in Apple's case when they're in so many different industries and markets, and they're in consumer electronics, they're in the software business, the services business, the hardware business. They're in so many different industries that, I guess it kind of comes with the territory. So yeah, I guess just another week in the industry. But with that, let's get into this week's cybersecurity tip. One thing that's fairly common as far as attacks go for cyber attacks is phishing attacks. And I think a lot of people tend to think that phishing attacks are mostly just relegated to emails. And while that was definitely probably the advent of phishing attacks, no more, because phishing attacks are also possible through messaging services. In this case, we're going to be talking about coming through RCS and iMessage, because there has to be a service for everything, where there's something as a service. You have your software as a service, your platform as a service, your infrastructure as a service. There's pretty much everything as a service. And apparently there's also phishing as a service, because of course there is. But one thing we of course have to clarify is when we say phishing as a service, we don't mean the profession of fishing and being a fisherman. We are talking about phishing in the sense of cybersecurity, where you are trying to gather credentials or people's information for evil purposes. So there's a particular, I guess, phishing as a service vendor, I guess is what you would call them, called Dracula. And they're basically using They use RCS and iMessage in order to bypass some of the standard SMS firewall restrictions to allow them to get away with these phishing attacks. So, due to the whole end-to-end encryption that's incorporated into RCS and iMessage, that's basically, on the one hand, the end-to-end encryption is nice because it ensures that no one can be snooping on your private communications. But on the other hand, if everything's encrypted, it's a lot harder to filter messages and verify the contents of these messages for possible phishing attacks like you can with SMS, which of course is not encrypted whatsoever. So, which is why you're able to do that kind of filtering with SMS, but you can't with messaging protocols like RCS or iMessage and theoretically also like Signal or Telegram as well. But when it comes to the phishing attacks, specifically when we're talking about these messaging systems, there's some common red flags to look out for. First off, if you get a message from either a number or more specifically with these phishing attacks, what it seems to be email addresses, that's obviously a red flag number one, especially if you see some random looking email sending you an iMessage with a link. I don't care if it's something about like your UPS delivery. It's pretty much almost certainly going to be bogus. So don't be clicking on those links because that's how they get you with the phishing attacks. So yeah. Now, because like for instance with iMessage, you can essentially just create an Apple like. Technically, it's limited on who can do these phishing attacks, but I mean, all you have to do is create an Apple ID and you can use iMessage. So, and with how randomized these emails are, I mean, it's pretty easy to just keep spinning them up and sending out these phishing attacks. Now, one way that you can actually protect yourself from this is you can download like filtering apps for your messaging app to essentially prevent this. So for me personally, I have a filter set up on my phone because there was a time, it wasn't like phishing attacks, but I was just getting a bunch of random spam messages for like no apparent reason. And it was getting really annoying, so I broke down and got an app to essentially, I basically was able to customize it to create rules to allow certain messages through. And one of them was essentially if it's a contact that I don't recognize and there's a link in there, basically just filter it out and ignore it, which made my life a lot easier. Nowadays, I don't really get any of those messages anymore. So whatever, I guess, spam was going out towards my direction has subsided, but I still have it, and occasionally I'll see things still get caught with that filter. Now, sometimes there are going to be some false positives, of course, nothing's perfect, but it's definitely a good way to prevent, a lot of these bulk phishing attacks like this. And of course, because it doesn't immediately delete the messages, you can obviously go through and check if you do have a message that got filtered to the junk or whatever, you can check it just to make sure that it's supposed to be there. Because like I said, there have been false positives in the past. But yeah, so phishing, not just for email, so definitely something you want to be wary of in messaging as well. So that is your cybersecurity tip for the week. So I mentioned talking about some tech buzzwords and what they really mean. So let's kind of get into that first here. So the one tech buzzword which you'll probably hear, especially within the past couple years, is AI startup. And the translation for AI startup is we use ChatGPT with some prompt engineering we learned after watching a YouTube tutorial. Which, I mean, I feel like the whole AI startup thing is kind of like the various gurus. It kind of gives you that like YouTube guru vibe, where it's like, I don't know. I mean, I guess, you slap AI on anything these days and you just get a bunch of venture capital funds, and then you laugh your way to the bank. I guess that's how it works. But yeah, AI startup, thought that one was pretty good. Legacy code is another one. So the translation for legacy code is so important we can't get rid of it, but we don't want to pay either. Which, I mean, we talked like, I think it was last week when we were talking about MS-DOS and how old it is, and how there still exists instances of it running in the wild in production. And it kind of goes to that's kind of like the definition of legacy code, right? Like, if you're running something that's still, the application is still running on, say, like MS-DOS or even Windows XP or something like that, and the reason you still have that operating system running is because you need it in order to support that application, that's basically the definition of legacy code right there, where it's really important, and if you get rid of it, it would basically destroy your entire production line or your service or whatever you're trying to do. But you're, at the same time, you're not upgrading it to something newer. Now, sometimes, I mean, like I kind of mentioned last week, like I feel like if you've been using something for over 20 years, like you get to the point where, yes, it works, and if it ain't broke, don't fix it. But at the same time, if you're using whatever application that is that, say, like integrates with hardware, for instance, like it's some kind of like assembly line robot or something, I would think you'd be getting to the point where you would need to upgrade the hardware, like once you get like that old, and then in which case you could upgrade the software too. I don't know. But it's not just relegated to, ancient operating systems. Like, there are also other instances where people are still using like older versions of Red Hat Linux, for instance, like still using RHEL 6 or well, I guess technically RHEL 7 is still supported for a couple more months, but there are definitely instances where people are still using like unsupported operating systems because that's what their applications work for, and either they or the vendor or whoever hasn't updated or hasn't paid to have the application be updated to work on a newer operating system. And I mean, it kind of gets back to that translation, right? So important we can't get rid of it, but we don't want to pay either. So thought that was kind of good as well. The next one is a classic, which is cloud computing. And the translation given is paying extraordinate fees to rely on someone else's infrastructure that you have no control over. Which, I mean, that is 100% true, because the cloud, as the saying goes, the cloud doesn't exist. It's just someone else's computer, which is 100% true. The next one is technical debt, which we did talk about technical debt a few episodes ago. And the translation here is move fast and don't fix things. And that's basically how technical debt accrues. You move fast and you don't allow the developers time to either, one, properly implement things, or two, give them the time to go back and fix things or improve the API calls or improve the implementation of stuff, and basically make the code base more and more unmaintainable until it gets to the point where it's just an absolute nightmare to make any changes whatsoever to the code base. Which then you get to the point where, after like 5-7 years or so, you get to the point where like, all right, well, let's just scrap what we have and just start fresh, and we can accrue the more technical debt as we go, and then scrap that and then start again and snowball till the technical debt becomes too massive, get rid of it, and repeat. So kind of the stereotypical definition there. The next one, agile development. The translation for that, admitting you have no plan. Now, agile development is actually a legitimate development process. So there are a couple of them out there. Agile's one of them. Before Agile, kind of the big name of the game was Waterfall. And kind of so Waterfall was essentially you start and then you go down and down and down. So you start at, like, say, your requirements gathering, then you do the design phase, then you do the coding phase, then you do the testing phase, and then you have your massive delivery. So this is kind of, what development was like, back in the 90s and early 2000s, or if you're the government, because the government moves super slow when it comes to anything related to technology, maybe you're still using Waterfall. I don't know. But the stereotype there, of course, being the government moves very slow. So when the industry is finally discovering, like, two things after DevOps, whatever that may be, the government will be like, hey, did you guys hear about DevOps? Now, of course, that's an over-exaggeration, but so Agile is another development cycle, and pretty much the goal of Agile is to have much more frequent but smaller releases, and you work in sprints, which are generally like 2 to 3 weeks or so, and in that sprint you try to knock out as much as you can, and it deals with story points, and every code change, whether that's a bug or a feature, has a certain number of story points, and then which technically story points have no value. They don't mean anything. You just make them up. Literally, you just make them up. Now, I will say, while you do just make them up, once you've been developing and you've been kind of doing the Agile process for a while, you kind of get to understand you get a better understanding of, how much story points actually are. But at least in the very beginning, they're completely meaningless. But I think the reason why this idea of Agile being you don't have a plan is because, unlike, say, Waterfall, where you literally plan everything out from the beginning, Agile is kind of more of a loosey-goosey, I guess, if you will. Like, it's more free-flowing and agile, hence the name. So it's kind of, if there's like a bug that comes up or something more important that comes up, you kind of pull that in rather than maybe going along with what you had originally planned on doing for that sprint, for instance. The next one, test-driven development, is translated as guessing the future one test at a time. Which, I mean, in reality, you should be testing your code. But I guess this translation is you just kind of hope and assume that it works, and you just test as you go. Another one I heard was like testing in prod, or like testing in production. Like, rather than, having a development environment or something to test your code in, you just push it to production and then let the end users test it for you and have them discover all the bugs and issues, and then you can fix it that way, which obviously is a horrible idea, but it technically is an idea. It could give you a bad reputation, but I mean, nothing can assure that you're finding a lot of the bugs than pushing buggy code to your end users for them to find the bugs for you. The next one here, open source, translated as asking someone else to fix it. Now, I don't necessarily fully agree with this one, because open source, maybe it's because I'm biased, but I think there's definitely a lot more to open source than, asking someone else to fix it. Now, if you're looking at, say, the business aspect of it, you could technically make the argument that this, from the business perspective, this is what open source is, because if you find an open source project that does what you want to do, you don't have to write it yourself. So in that sense, I get it, but there's definitely a lot more to open source, in my opinion, than having someone else write your code for you. The next one here, CI/CD, or continuous integration, continuous development, automating your mistakes into production. So this one, kind of going to, we'll test it in production, I guess, which, the whole point here with CI/CD is you push your code, and then based on that push, you'll have some kind of like test, ideally anyway. You push your code, have some automated test suite run to test your code to make sure it's tested and working. And, well, of course, before that, you'd build the code, make sure it builds, and then you go through all of your test cases. And then if you're doing DevSecOps, you'd have a security scanning phase in there where you'd run through some kind of security audit to check for known vulnerabilities and whatnot. And then, assuming you get through those steps, then you go to the deployment phase where it gets pushed to wherever your production servers are and into production, and all you had to do was do a git push, for instance. So definitely automating your life, but if your test cases aren't up to par, then yes, you absolutely could be automating your mistakes into production for sure. The next one is API, or application program interface, asking someone else to do it. So kind of along the same line, I guess, as open source. But in essence, that is basically what an API does. You're calling a function that does something that you don't have to write the code for. So, you have your common, APIs from various websites that allow you to tap into, their infrastructure. Like, for instance, Twitter and Reddit have their own APIs for you to query stuff. OpenAI has their own API that allows you to, use their AI models to integrate into your own applications. Graphics libraries have APIs to allow you to call functions to handle graphics components. I mean, there's a lot of various APIs to do various different things, but again, the point is you call the function from the API, and then that API does stuff in the background to handle stuff that you don't have to write the code for. The next one, we already kind of mentioned this one, DevOps, the belief that more tools fix any problem. The thing with DevOps is some get this mindset in their head where you have to have a lot of various tools in order to do DevOps. But in reality, DevOps isn't about the tools you use. It's about the mindset you use, which is kind of developing and the operations side kind of together. So you don't only, like in the older days, you would have your developers and then you have your operations teams. And basically your developers would write the code, they would send it over to the operations teams, which would handle the whole deployment aspect of it. But if there were any issues, they would kick it back to the development team to fix those issues. So the point of DevOps is to essentially combine those into just one role and have your developer use various tools, whether that's Jenkins, GitLab, whatever you're using, to essentially handle the various automation tasks for you to handle that continuous integration and continuous development. But at the end of the day, the DevOps isn't about the tools you use, it's about the mindset you have of essentially combining your development and operations into one mindset, rather than you're the developer, you write your code, you do some testing, and then you throw it over the fence, if you will, to the ops team and kind of like wipe your hands and go about your day, and essentially just combine those. The next one, microservices, creating enough small problems to avoid one big one. And, that's kind of what microservices are. Kind of the goal of them is to divide up the problem into, small, easy to maintain and manage subtasks. So we talked a few episodes about the microservices architecture. So if you haven't listened to that, definitely go listen to that after this episode. The next one, cybersecurity, playing hide and seek with the hackers. So, I guess it depends on how you look at cybersecurity. If you look at cybersecurity specifically from I guess the defense perspective, to me, this interpretation here, the playing hide and seek with the attackers, to me that kind of screams security through obscurity, like you have a proprietary code base or something, and the way you protect yourself from hackers is by keeping everything proprietary and trying to obscure things in your binaries and in your code itself, which, in all honesty, is a horrible cybersecurity practice, in my opinion. The other way you could think about cybersecurity is, I get another mindset you could think is if you're thinking more from the defense aspect. So often in cybersecurity, you'd kind of do what's called like red team, blue teaming, and where you have your red team, which is trying to actively exploit or hack into a system, and then you have the blue team that's trying to defend. So whenever you're trying to really test something for cybersecurity, the thing you want to really think about is you want to get into the mindset of a hacker and think about what they would do and how they would try to exploit the code in order to better defend against them, and basically develop ways to protect against those common things. So, for instance, the easy one, we talked a few weeks ago about the memory vulnerabilities with C and C++. So the easy one there is to not take in arbitrary input from the user and do a string copy into a set buffer size, and you don't even bother to check the length. I mean, that's just, number one right there. That's a super easy one. So, identifying things like that, and of course, always assuming that everything that comes from the user is malicious until you can verify otherwise that it's not. Coming up with, some of those kind of cybersecurity practices. But I guess at the most basic, dumbed down level, I guess you could say it is playing hide and seek with the hackers, because it is kind of like a never-ending arms race where you come up with ways to protect yourself against them. They come up with new exploits. You have to patch those exploits so they can't exploit them anymore, but then they come up with new ones, and the cycle continues. The next one, serverless. Pretending servers don't exist until the bill comes. So that kind of goes in line with the whole cloud computing thing and the microservices. Those kind of all go hand in hand. So generally, microservices and serverless are essentially, they're not one and the same, but they're kind of one and the same, because a lot of times when people are using microservice architectures, they're using a serverless infrastructure, if you will, and essentially kind of using something like, I think it's AWS's Lambda functions to essentially, when they only run the code when it needs to be run, at other times it's just idling, so they're not, housing VMs that are just sitting there at, 10% usage 90% of the time, and then 2% of the time they're maxed out beyond belief and can't handle the traffic. So kind of the point or the goal of serverless is to, yes, pretend servers don't exist, because the whole managing the scaling up and down of the infrastructure is all handled by the cloud provider, or handled by the other person's computer that you're using, rather than you having to manage that infrastructure yourself. This one is the last one, and potentially might be one of my favorites. Scrum. Group therapy for being behind schedule. So Scrum is, like I kind of mentioned, in the nerdy things segment, should call it the weekly Scrum. The point of the Scrum meeting is it kind of goes hand in hand with Agile, just to make sure kind of everyone's on task and, what you're working on. If you're running into any issues, you bring those issues up, and then someone else might be able to chime in to help you out. Kind of just like a brief, quick status for the day, essentially, is kind of what a Scrum meeting is. But I think it is kind of funny where they say a group therapy session for being behind schedule, because you can only plan so much, right? There are always going to be things that come up that you couldn't and didn't plan for. And that, of course, lends you being behind schedule. And then I guess here comes the group therapy session of, I didn't get my change done this week because I ran into this bug and been, banging my head against the wall. And then, everyone kind of has that, a similar thing from time to time. And I guess you could make the argument that is kind of like a group therapy session. So I hope you kind of enjoyed this little bit of fun we had here talking about tech buzzwords and kind of giving their true meaning, if you will. And with that, let's get into what nerdy stuff have I been up to this week. So I mentioned at the very top of the episode, revisiting the cache discussion from last week. And again, if you haven't listened to last week's episode, you're definitely going to want to listen to that because it'll help put a little more of this into perspective. But I decided to write a C++ program to optimize for cache hits to try to prove my point and gain a better understanding because, like I said at the top of the episode, I didn't feel like the explanation I gave about how cache performance can really improve the performance of your program, I didn't feel like I really drove that point home. So I decided to write this program. So of course, like I said, the goal of it was to write the same exact code and be able to toggle between optimizing for cache hits and cache misses. So the way I went about doing this is changing how I accessed elements in the same array. So I created a 1000 by 1000 array that optimizes for cache hits by incrementing from 00 to 10 to 20, and then iterating for cache misses by going 00, 01, 02. So, of course, if you're going through that in a nested for loop, literally the only difference is you're swapping your X and Y or your I and your J or whatever your iterative elements are. So essentially all I was doing to simulate quote-unquote work was to force the compiler not to optimize it out, was to give the function a seed value, was what I called it, and then each iteration through the loop, it would basically take that seed value and add I think it was one of the iterator elements. I forget exactly which one I chose, but essentially I would run the application, run the program for 5 seconds, and essentially each time through the loop, I would pass in like the current timestamp as the quote unquote seed, and then use that for the adding portion to actually simulate work, so the compiler couldn't just optimize it away. So that was the goal. And of course, since we wanted speed, I compiled with the OFast flag to help ensure as much speed and performance as possible. Although the cache miss variant, that OFast flag did absolutely nothing to the performance, and it did the exact same. Although the cache hit variant did significantly better with the OFast flag compiler optimizations turned on. So let's get into these results. So the cache miss variant averaged around 710 passes in 5 seconds. And that's, of course, with both optimizations on and optimizations off. So turning on optimizations did absolutely nothing in this case for the cache misses. So for a little more context, that 710 passes roughly in 5 seconds equates to about 7 milliseconds per pass or so. Now, take a guess at the cache hit variant. So with no optimizations, absolutely none, with just doing the G++, no optimizations whatsoever, it completed roughly 2,170 passes in the same 5 seconds. So we're going from 710 to 2,170, which is roughly an average of 2 milliseconds per pass. So this is kind of what we talked about last week when we were talking about the cache performance. Like, if you actually think about it, if you only had one instance where you had like, a 4 to 5 millisecond delta with having a cache miss versus a cache hit, generally speaking, that's probably not going to make much of a difference. But again, like I mentioned, if you constantly have that miss over and over and over and over again, it can add up to be fairly significant. And as we can see here, that's roughly like a 205% increase in performance by optimizing for cache hits, and we literally didn't do anything else. Now, with that said, getting to the optimized version of optimizing for cache hits and using that fast flag, we got a whopping 27,000 passes in 5 seconds. And let me tell you something. When I was testing this, the variance in the number of passes in the optimized version was more than more than the cache miss version. So essentially the various small deltas I would see in the difference in performance of the optimized version, because again, you're not always going to get the exact same because other things are running on your system. So it's obvious that's why you run things multiple times to kind of get an average. But between the max and the minimum, it was more than the number of passes for the cache miss variant. So essentially, the optimized version was doing all of the miss version plus like an additional 27,000, which is absolutely insane. So for a per pass number, it was essentially doing this in 0.185 milliseconds per pass. So the cache hit variant with no optimization flags was about 2 milliseconds. The cache hit variant with the fast optimization flags was 0.185 milliseconds. So, and it, of course, on a per pass basis, that's not, on the surface, that doesn't look all that significant, right? Like if you only ran it once, to your eye, they would finish at the exact same time. They'd be basically instantaneous. But the thing is, when you have this going over and over and over again repetitively, that's where you really start to see the improvements in performance. And again, the only difference here in the code between the cache hit variant and the cache miss variant was how we indexed the array and the elements in the 2D array. That was literally it. Everything else was exactly the same. And in the case of compiler optimizations, I mean, that's essentially quote unquote free performance because you're just tacking on an optimization flag. So it's quite impressive. Now, I guess the other thing I should also point out was I didn't try to cheat this at all and, perform the cache miss variant on some ancient piece of machinery from like the 90s and then run the cache hit variant on, the latest and greatest processors. No. This was all run on a 2012 Mac Mini with an i7 3720QM. So a fairly old machine on a fairly old CPU, and we were still seeing these massive performance differences. So like I said, just manually optimizing for cache hits, no compiler optimizations at all, we saw an increase of 205%. And then with the compiler optimized version, we saw a 3,700% increase in performance, literally again by just changing how we index an array. That was literally it. So all of this kind of to show you that doing minor optimizations like trying to optimize for cache hits can absolutely be astounding for performance, especially when you get to scale. Because like I said, these were only 5-second tests. And if you can think of this as, user requests coming into your game server or coming into your website or whatever your application is, if you're getting a lot of these requests, being able to handle 27,000 requests in 5 seconds is very much more preferred than 710 because with the 200 or the 27,000 you can maybe not necessarily skimp on hardware per se, but you could get a lot more out of the hardware you have. It will get you a lot further. So yeah, needless to say, I knew that optimizing for cache hits made a difference, but actually seeing these numbers and running this experiment was still quite astounding, to say the least. So it just kind of goes to show you that a few clock cycles here and there can really add up over the course of a runtime of a program. So that was kind of the thing on cache that I wanted to revisit. But in addition to caching, I also, literally just this morning, or I guess it was technically last night on the day I'm recording this, my home lab was firing on all cylinders. And so basically, as a little bit of a background, this morning I woke up to another instance of notifications that my home lab was inaccessible because for whatever reason my internet was down. And the thing that was awesome about it, though, and the reason I'm bringing this up, is my IP address changed. So for the past, I don't know how long, I've had the same IP address, and it almost was like I had a static IP address because it was just unchanged for so long. And I had talked about a while ago on the podcast how I wrote a script to basically check to see if my IP address changed. And the only time that I saw that script actually work was when I forced it to think my IP address changed, and that was the only time I was able to actually see it work in the wild. But today, so I saw, I think it was 3 notifications saying my home lab was inaccessible, and then right after that, I see a notification saying my home IP address has changed to new IP address. And I was like, interesting. And then, of course, after I got that notification, no more unable to connect to the home lab notifications. So basically what happened was my internet went down, and then when it finally decided to come back up, I guess I lost the IP address I had, so my ISP issued me a new one, and then the script that I have to check my IP address noticed that change, updated it, sent the change to my VPS, or my virtual private server in the cloud, to allow me to check to see if my home network is accessible or not. And then the next time the VPS tried to connect to my home lab to perform this check to see if my network was up, that script, before it tries to connect to my home lab, it essentially checks it pulls the IP address that my other script, the one that pushes the IP address change, it pulls the IP address from that file that the IP address change checker pushes. So it basically pulled the new IP address, updated the VPN config, tried to connect to my home lab, was able to, and everything was all good. So I have had this happen before, but like I said, the only time I was able to trigger this was when I manually triggered it by essentially removing the file on my server that does the reaching out, the checking for the new IP address. So basically how that script works in a nutshell is it stores in like just a plain text file what my current home IP address is, and then it reaches out using an API call to a service to basically check what my IP address is, which honestly isn't that hard to do at all. So I query what my current global IP address is, compare it to the one I have saved, and if they're different, then I update the one that's saved and push that updated version to my VPS, so I can either check it from anywhere I can log into the VPS, see what the IP address is, or in this use case, the VPS will pull that IP address and update the VPN config accordingly to be able to access my home network. So prior to today, the only way I was able to get that whole thing to trigger was when I would either change the IP address manually in the saved file on my server that does the IP address check, or just delete it entirely and it would generate one and do the whole shebang. So it honestly put a huge smile on my face to actually see this working in real time. Well, I guess technically not in real time since it happened in the middle of the night and I was asleep, but to actually see it happen for real was quite awesome. And, it's really nice to see, your home lab fire on all cylinders, and these measures you put in place to check things like this actually work as you intend. And to see them actually work for real was quite awesome to see. Now, getting into the Scrum portion of the nerdy things, I did have some updates to my video game, though not many because we'll get into it in a little bit. But I got the initial support for the party screen working. So I had mentioned the past couple weeks I'd been working on the individual Pokemon summary screens. So you could basically see, the Pokemon itself, stats like the trainer ID, ability, met location, level, stats, moves, that kind of thing. You could reorder the moves. That was the most recent thing I did. So this week I managed to get initial support working for the Pokemon party screen. But I say initial support because literally all it does is, right now it's a glorified wrapper to allow you to cycle through the summary screens of all the Pokemon in the party, because currently there is zero way for you to select which one you want and swap, their positions in the party or anything like that. That doesn't exist yet. I just wanted to get some kind of way to cycle through, the different Pokemon summaries in the party, because of course that's eventually going to be a feature anyway, so getting that working now was definitely good. But now I essentially have to work on the interface to the interface to allow you to do that, so that's going to be something that I'll probably be planning on doing next. But of course I also did some refactoring, updating variable names to align with kind of the naming convention I came up with. Because one thing that I did recently, with pretty much since I came up with the Clang format thing, which I also talked about a couple weeks ago, was to come up with a solid naming convention thing, because I kind of had one, but it was kind of wishy-washy. Like sometimes I would use it, sometimes I wouldn't. So I kind of concreted that this week and tried to, at least as best as I could, trying to manage over 17,000 lines of code, trying to make sure everything was updated. So to the best of my ability, anyway, try to do some updating with that. And then I also did some memory allocation updates, because there were some instances where I was being a very bad programmer and not checking the memory that I was receiving from allocators to make sure that it was valid, which is obviously not a good thing, because then you could be accessing null and crashing your program, and I wasn't doing a very good job at that. Sometimes I would do it, sometimes I wouldn't, so I basically kind of went through, clean house, and did a better job of actually checking for things like that. But here comes the fun. Well, I guess it depends on who you ask, but I was not done playing around with MS-DOS. So I decided that I would create a vector implementation for C. Now, yes, I know there is a GitHub repo out there that already did this, which, in fairness, I probably could have guessed it already existed, but I didn't confirm that it existed until after I already started working on it. But the goal of this is essentially to create the std vector standard container from the C++ standard template library, and basically make a C equivalent. And the TLDR, or the short version of how this works in C, is it's basically pointer arithmetic everywhere. So I think we talked a little bit ago, it might have been even last episode, about how pointer arithmetic works when it comes to arrays. So essentially how arrays work is it's just a contiguous block of memory, and the way that you access each element is you identify the start address, which you already know. That's what your pointer does. It points to the beginning of the array. And then because you know the type of the array, say it's an integer, you know that each integer is 4 bytes large, so all you have to do is add 4 bytes to your address, and then you get to the next element, and so on. The problem with trying to create a vector in the case of C is there are no templates, so essentially you have to use void, but void has no definition of size, so you have no idea how there is no concept of this is an integer, so I go 4 bytes and I'm at my next one. You can't do that. You can't index into an element in a void array. That you can't do that. So basically what you have to do is when you create the vector initially, you have to prompt I guess in air quotes, you have to take in the type that this vector is, which is basically how C++ does it anyway. When you create a vector, you have to give it a type as the template, because basically the template is you give it what type it is, and then it can house that type of object, whether that's an int, a double, a custom type, or struct or class, whatever. So in the C world, how I implemented it is it takes in the type that you're wanting to create, so whether that's an integer, some other structure you created, whatever, and it'll essentially identify that, get the size, and then store that as part of the vector object and then or structure. And then whenever you try to access a given element in the vector, it basically does the pointer arithmetic that's really going on behind the scenes when you deal with arrays, of manually calculating the memory index of the start of the thing to return, or the start of the memory address to start copying data into, or what have you. So lots of pointer arithmetic, but I will say, while the vector isn't necessarily all that complicated to implement, because really going into this, I didn't think it was going to be that hard at all, because the biggest thing that you have to kind of account for is the reallocation of the vector, essentially checking to see if you're at the maximum capacity and then resizing it and all that stuff. So it's really not all that complex, but I will say, going through this process of implementing a vector data structure and really getting into the nitty-gritty of, essentially the behind the scenes of how arrays work and how the pointer arithmetic works, has definitely been a fantastic learning experience. I will say that. But of course, like I said at the beginning, I was not done playing with MS-DOS, so literally all of the development that I've done with this vector project currently has been entirely in MS-DOS. With the development environment that I set up that I talked about last week, I've been coding 100% of this in DOS, which honestly has been a lot of fun, because while I don't get my syntax highlighting and I don't get my autocomplete for functions, and it's not as easy to have multiple code windows open at the same time to reference things, it's honestly been a lot of fun. I have been really enjoying it. It's honestly kind of nice to kind of go back in time and to a more primitive age, if you will, of coding and writing in the original C standard, the ANSI standard, C89 or C90, however you want to describe it. And the really cool thing about this is I unintentionally, by writing I guess technically I could have done it on a newer OS that's actually supported and still would have had the same outcome. But because I'm writing it on MS-DOS specifically, and the only C version I can use is the ANSI version, I'm essentially making this compatible with literally anything that can compile C code. Because one of the things with modern C compilers is generally, from my understanding, it seems like they kind of default to either the C99 or the C20 or 2011 standard. And unless you specifically specify which standard you want to use, it'll kind of go to that default. So if you want to kind of write code in the ANSI standard, you essentially have to specify that at compile time with a compiler flag. in order to ensure that you have that compatibility, because as I kind of discovered last week, C code that works on, say, the C99 standard does not necessarily work with the C89 or the ANSI standard. So I'm basically unintentionally writing C code that'll work for any platform, kind of by accident, by doing it all in MS-DOS. So at the end of the day, this could not only work on 64-bit machines, but also even 16-bit machines, because MS-DOS was 16-bit, of course, back in the day. As far as 8-bit, I'm not sure if it would have support for like 8-bit machines, although I guess assuming you had a C compiler that could compile the ANSI standard of C code, in theory it would work. But yeah, so that's one thing that I was working on this week, and I am planning on pushing all that to my GitHub once I actually kind of get it more finished and ironed out, and kind of putting, I don't know necessarily about instructions about compiling it on all the various operating systems, but I'm 100% going to make a point that it can essentially be run on anything, because if it can run on MS-DOS, as well as modern operating systems, I mean, we're kind of running the gambit there. Basically, anything that can compile C code, this, I guess, library, if you will be able to run on it. So that was the nerdy things I did. And we talked about MS-DOS, which, if you remember, was also the topic of our trivia question for the week. So our trivia question this week is, MS-DOS is an operating system, but specifically, what does MS-DOS stand for? And if you said Microsoft Disk Operating System, you are correct. So I kind of gave you half of it right there. And if you know what MS for Microsoft means, all you had to do was guess what D stood for. And that may or may not have been challenging, although, I mean, last week we talked about MS-DOS and using floppy disks, so I don't know if that kind of potentially gave it away. Hopefully some of you got it right this week. Hopefully it wasn't too challenging for you. And if you enjoyed the episode, definitely give it a rating and review, and subscribe if you haven't done so already, and share this episode around and the podcast around. And if you have any questions about this episode, or if you have any topics or comments for future episodes, feel free to shoot me an email at contact@darkassassinsinc.com. There's a link, as always, in the show notes down below. And that's going to do it for me in this episode of the Dark Assassins podcast. Until next time, my fellow assassins, remember, bool nothing equals true. If action not equal to null, return true. I'll see you next time on the Dark Assassins podcast.